Good afternoon, my name is Rodrigo Siles. I am a student of in Arundel Community College. I try to achieve my degree in mechatronics, and also I would like to present my capstone project. My capstone project consists in develop an electronic card to control through Arduino in a PC, a medium and high and low electronic devices, like for example stepper motors, electro valves, control directional valves, and that's the examples I'm gonna use to demonstrate the use of the card I designed. Well, one of the important points of this design, I divide the design in three main parts: the power pipe part, the second one which controls the motors, and the third which controls the insulate the system, the power system, from the data system, which is the computer and all the information that is created. And also I have created on top of this card goes this card, which is responsible to control high voltage, AC current, and also DC current. Yes, I would like to make now a little description what is in this card. I create a portable model where I can test every single chip in order to make sure the function is according what I want to achieve, right? And also I would like to show, for example, all this project has a main application, like for example this hybrid 3D printer which I am working on. Yes, it's a 3D mix with a CNC machine, and it's basically designed to produce microvalves or human organs, human artificial organs. The resolution what I create is very small. They are very small refined steps what is programming these motors especially, but in order to allow to achieve this small and precise movements, I create this card. Basically which is consisting in 4 edge bridges with opto insulators, and use the Arduino Mega, and also the power supply. I generate 18 volts, 5 volts in a variable power supply. I would like to demonstrate, for example, the values what I achieve in the power supply, and then I'm gonna move to the basic function of the card, and then I will make 2 small examples about how works the system. In order to do that, let me use my voltmeter, calibrate in DC power, and let's see what we can do with this. So let's first try with the 18 volts. The 18 volt, let me put it on right there in the positive and the negative, and let's see. As you can see, it's 18 volts. You can see in the card at 18 volts. Now let me try with the 5 volts. Let's see, 5 volts. 5 volts, between 5 and 6, it's oscillating. Okay, perfect. So I have this main supply, and I have, for example, my power supply generator in order to regulate from 0 to 36 volts this electronic card. And also I can use this system and plug it up in the system and produce my own power supply. Also goes from 0 to 36. Yes. Having said that, I would like to introduce my begin with the explanation and the application and the stepper motors, right? So let me plug it up the Arduino. Perfect. So let me activate the power supply and let's begin, for example, with the analysis and the stepper motors. We're gonna take a look. So as you can see, it's beginning to move the stepper motor in high precision. See? As you can see, it's very undetectable, the movement of the whole piece. But I will do like 3 small process in order to see the precision what I try to achieve in this machine. But my main claim is actually is the design of the card which is able to control these motors. So now let's see, for example, what happened with another stepper motor, especially with the grabbing tool, which I designed in a very interesting way. So it's beginning. So begins, yes, as you can see, it's very small stick design, right? It's very high accuracy, very high precision. I'm sorry, movement. After this, I'm gonna run two shots about the function of these two motors. Let me show you first which part of the card is working. As you can see, I have to overcome so many problems, especially with the heat generation in the element. I create a small power supply, 5 volts power supply, in order to achieve a very good precision movements in the stepper motors. Let me go back again and see when it's going to stop this movement. Then it's going to take again. I will gonna take again the same process, and then I will move to the other two motors, this one and this one. Let's see when it's going to stop and the precision and the timing. The pulse width modulation what I create is I did by program. Let's give it a minute and it's gonna stop the meter. Boom. Okay, so we have now the first step. Now it's gonna go according with the program with the second movement. Okay, let's give you a minute and it's going to begin the process again. Last 1 minute, just wait a minute. There you go, start to the second movement. And it's going to produce basically the same horizontal movement. I would like to, if you are curious about what is about this machine, this machine is designed specifically to create thickness, artificial thickness. Yeah, the interesting feature about this machine, I can install 1, 2, 3, 4, 5 different CDV valves plus the piston, and I can inject the 4 elements of DNA and create any cell I want, or any helix combination I want. Let's begin with the other one. There you go. It's moving. Let me also mention this machine comes is constituted by 4 stepper motors, 1 big regular motor, some type of drill or router, whatever is the purpose you are following, and also per suite. I'm sorry, and also I have this stepper motor which goes back and forth, up and down, and I have this motor which goes up, simulate like a pendular rotation. See, this is one of the generations, and then I will unplug and I plug to the other two stepper motors and show the functionality of the electronic car. Let's give it a minute. Let's see what's happening here. It's going to stop in short. There you go. Stop. So allow me please to unplug these 2 motors and plug it up to the other one. So please give me some minute to do that, and I'll be back in shortly. Okay, so let me unplug this. And there you go. Turn off the power supply. Take the Okay, as I mentioned before, I would like to present the next generate the movement in the next 2 stepper motors. Let me plug it up in the system. It's done. Power supply. So let's wait now for the movements. Okay. So I have this thing, these 2 plugs connected. Okay. So as you can see, you will see in detail the movement of the stepper motor. There you go. It's coming up and down. I'm gonna demonstrate this process twice in order to make sure my claim is correct. for my capstone thesis. And let's wait for a minute and see. There you go. I start moving the other part. This is correspond to the wheel, and this one basically what it does is move the pendular wheel, which is very high precision movement. Yeah, very refined according with the necessities you have to achieve when you want to create a micro valve, or you're going to set up some type of liquid or organic material. I would like to thank the school, Arnold Community College School, especially to Mark. He was able to help me up with the lacing care of all these elements, and also I would like to give it say thank you very much to the Professor Peggy Walton for her support and collaboration, and also to the Professor Tim Callahan and James Sherman. See, as you can see, the movements going back and forth. And let me show you some part of the code. Yes, I create my own libraries. Not my own libraries. I create my own functions, right? To control the movements of the stepper motor. The motor is working right now. See, it's about to stop. Stop. So now let me explain a little bit about the circuit that I designed to control the stepper motors. Comes for 1, 2, 3, and 4. I'm sorry, 1, 2, 3, and 4 H-bridge motor controllers. Yeah, the terminals for the opto insulators and all the wire distributions. See, power for the this is the power for the data information, power for the motors, data information for the motors, and that's the outcome, the information that goes to every single stepper motor. So, and also I would like to explain the concept of that is designed to control these valves. Right now I'm let me take it out. See, this card is designed specifically to control AC power and DC power, high voltage DC power. See, I will make a small video about that in the next part of the presentation of this process. Yeah, and I would like to say thank you very much. If I make any mistake in the language or the communication, please forgive me. That was not my intention, right? As you can see, English is not my first language. So thank you very much, and I will present in shortly the next video. Thank you.